Hello everybody, so Beaton here and welcome back to another past paper practice video. In this video, I will be looking at some algebra, multiple choice type questions. So let's get straight into the first one. So this question says, when twice a certain number is subtracted from 7, the result is multiplied by 3. The answer is 33. What is the original number? So it's saying when twice a certain number, so we don't know what that number is, it will be 2 multiplied by x. When twice that number is subtracted from 7, so we'll have 7 and we'll subtract this here from 7. And it says the result is multiplied by 3. So everything is multiplied by 3. And the answer is 33. What is the original number? So we want to find what is the original number, meaning we want to find the value of x. So we can distribute this 3 throughout here to get rid of the brackets. 3 times 7 would be 21. 3 times negative 2x would be a negative 6x is equal to 33. So negative 6x, so this 21 is added, we take the will subtract. This will be equal to 33 subtract 21. So negative 6x would be equal to 33 subtract 21. Remember, we don't have calculator, so 33 subtract 21 will give me, this will be 2 and 1, 12. Therefore, x would be equal to, so this negative 6x is multiplying. We take the will divide, so we'll have 12 divided by negative 6. And therefore, x is equal to 12 divided by negative 6 would give me a negative 2. So the answer is a negative 2, which is B. And we can think about it. When twice a certain number is subtracted from 7, so let's see. So 7 subtract 2 times negative 2. This is multiplied by 3. The result is 33. So let's see. So 3 multiplied by 7 subtract. So you can say negative 2 times negative 2 will give me a plus 4 is equal to, this should be 33. It's equal to 33. So 3 multiplied by 7 plus 4 would be 11. And this should be 33. So 3 times 11 would be 33 is equal to 33. So therefore, our answer is indeed 100% correct. So the answer is B, negative 2. So this question now says, given that 3 asterisk 6 is equal to 12 and 2 asterisk 5 is equal to 9, then A asterisk B may be defined as, so let's see, we have 3 asterisk 6 is equal to 12 and we have 2 asterisk 5 is equal to 9. I want to find which one of these here would make both of these true. So we can do some trial and error. So let's try this one. So let's try C. So C is 6A minus B. So first of all, let's call this one A. Let's call this one B. Let's call this A and let's call this B. So 6A minus B would be 6 multiplied by A, which is 3. Subtract B, which is 6. So 6 times 3 is 18. 18 minus 6 would then give me 12. So that checks out. Let's see if the other one will check out. So 6 multiplied by A minus B. So this will be 6 multiplied by A in this case, which is 2. Subtract B, which is 5. And they should work out to 9. So 6 2 is 12. 12 subtract 5 would definitely not give me 9. So that is out. So let's try another option. Let's try D. So 2A plus B. So this will be 2 multiplied by A, which is 3, plus B, which is 6. So 2 times 3 is 6 plus 6 would indeed give me 12. So this checks out. So let's write 2A plus B for this side. So 2 times A, in this case, A would be 2 plus B, which would be 5. So 2 times 2 would be 4 plus 5 is equal to 9. So this checks out. So the answer is D. So this question says, if x is equal to negative 2 and y is equal to 3 and t is equal to 2, then x over y all raised to t is equal to, so x over y all raised to the t power. So let's do some substitution. So we know x is equal to negative 2 over y, which is equal to 3, all raised to the t power, which is 2. So we know this would be the same as negative 2 over 3 multiplied by negative 2 over 3. So negative 2 times negative 2 would give me 4 over 3 times 3 would give me 9. So the answer is 4 over 9, which is simply B. So this one says, if 3 raised to the 2x plus 1 is equal to 9 multiplied by 3 raised to the x power, then the value of x is, so we have 3 And we have 2x plus 1 is equal to 9 multiplied by 3 raised to the x power. So here's the thing. These two things can be equal to each other if both of them have the same bases. So we can do, we can make sure that this side has the base of 3. So how can we do that? We can express this 9 here as 3 raised to the second power. And this will be multiplied by, so we can change this bracket and put it as multiplied by 3 raised to the x power. You know, 3 to the second power, open bracket, 3 to the x power is the same as this. All right, both of these mean the same thing, just different notation. So we know 3 to the second power times 3 to the x power, this would be the same as 3 raised to, we are adding the indices, so this would be 2 plus x. And this would be equal to 3 raised to the 2x plus 1. So since we have the bases are the same, now we can equate the powers. So we can have now 2x plus 1 is equal to 2 plus x. So we can put all the x's on one side. So we'll have 2x, this x is adding, take double subtract, minus x is equal to 2. So this is adding, we take double subtract, 2 minus 1. So 2x minus x would give me x is equal to 2 minus 1 would give me 1. X is equal to 1. And if you do substitution, we can see that is true. So let's see. 3 raised to the 2 times x, which is 1 plus 1. This will be, and this is equal to 9 multiplied by 3 raised to the 4th power. So this will be 3 raised to the 2 times 1 is 2 plus 1 is 3. So this will be 9 raised to the 3rd power is equal to 9 multiplied by 3 raised to the 4th power, which is 3. 3 times 3 is 9. 9 times 3 is 27 is equal to 9 times 3 to be 27 as well. So it checks out. So our answer is 1, which is C. And the last one says, John has X marbles. Max has twice as many marbles as John. Max gives John 5 of his marbles. How many marbles does John now have? So we see John started out with X marbles. And then Max got twice as many. So Max probably got 2x. So Max gives John 5 of his marbles. So John now has a plus 5 marbles. And I want to know how many marbles John will now have. So John, he has x plus 5 because 5 additional was added to his marbles. So it is x plus 5, which is B. And with that, this has brought me to the end of this video in which I tackled some algebraic concepts using some multiple choice type questions. And I want you to keep practicing these questions to get better. And I'll see you in the next video in which I'll be tackling some more multiple choice type questions. Until then, take care and keep practicing.